Okay, this problem gives you a lot of information about this rational function, which I have hastily copied down here. You have a nicer version on this test that you're actually working on, but it gives you all the key features. So the thing here is, it takes no knowledge really just to be able to copy down these key features, and that's what you should always do first. All right, show me that you can at least copy down the key features given to you. So if I have vertical asymptote at -1, and at 4, or -4, sorry, -1 and -4. Okay, so let's put those like right there. All right, and then I have a x-intercept at 2. So I'll put an x-intercept like right here. I have a hole at 5, 3/54, which means it's further along than the x-intercept, but just a little bit off the axis. I have a y-intercept at 0, -0.5. That like right there, and an HA at y equals 0, so I know I'm going to approach y equals 0. Okay, so we have the key features copied down. All right, that's step one. Now we have to think about how these are connected. Well, I have a y-intercept right here, and I have an x-intercept right here. So those two dots have to be connected in some way, right? So we're going to connect. We know that those are going to connect. We also know that we need to connect the x-intercept to the hole. And then we know that over time we need to approach our HA at y equals 0. Okay, what about this way? Well, we're going to run into a vertical asymptote. So with a vertical asymptote, we can either go to positive infinity or negative infinity. But in this case, we know we don't go to positive infinity because to do so, we would have to cross the x-axis again. But there's only an x-intercept at 2. So it's impossible for me to just randomly come up and cross it again, which means that this side of the graph must look something like this. It's going to come down, it's going to come through, okay, and then it's going to approach my HA. Okay, so there we go. That's that side of the graph. Now, there's other stuff happening. There's all kinds of graph over here, but we don't have any other like points or anything that we can build off of over here. But we do know that this vertical asymptote at -1 has a multiplicity of 1. The exponent right here is 1. Which is odd, which means that on either side of my vertical asymptote, I have to have a different sign. So if I go down to negative infinity here, I'm going to have to go up to positive infinity on this side. So then I guess technically there's two options here. I could come down like this, or I could come down and come back up. And I know that I come down and come back up because if I were to come down here, once again, I'd have to cross the x-axis, but I only have one x-intercept, so that is never going to happen again. So the graph must look something like this where it comes down and then comes back up. And then finally on this side, again, well, what are my options? I could be up here or I could be down here. I can't be in both because once again, I'd have to cross the x-axis. So if I'm up here, well, that means that I'm going the same way in my vertical asymptote, but once again, it has an odd multiplicity, which means that my arrows are going to point in different directions. I'm going to go to different infinities on either side, so that must mean I come down like this. And then over time, I have to approach that horizontal asymptote because it is there at y equals 0, so I'm going to have my graph approach it. And this is a poorly drawn but accurate sketch of this graph.